Alright, 8.1. Apply the Pythagorean Theorem. So what we're looking at here is how the Pythagorean Theorem is applied. So, a couple of words we need to identify. For example, hypotenuse. Hypotenuse is the longest side of a right triangle. Now, some of you may think it represents the longest side of any triangle. Well, no, folks. Hypotenuse is a special side in only a right triangle. And the hypotenuse is the side that it is the side that is opposite the 90-degree angle. So if we look at this right angle triangle, we can see that the hypotenuse is right over here. Now, how do we know? Well, see this right angle here? It always points to the hypotenuse. See how it's pointing to the hypotenuse? So that if I was to, for example, take this whole triangle and decide, let's see what it would look like if I twisted it. Well, guys, the hypotenuse would change, would move as well. It moves with the right angle triangle so that always opposite the right angle is the hypotenuse. I can move it around like this, and again, the right angle points to the hypotenuse. I can move it so that it's like this, and the right angle points to the hypotenuse. So the idea here, folks, is that you want to always identify the hypotenuse first. Once we identify the hypotenuse, we can use the Pythagorean Theorem. Pythagorean Theorem, which we're going to use PT for short, in a right triangle is the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides, so the two shorter sides. So if we have side A and side B, for example, we're able to determine the formula. The formula for here will be side A all squared plus side B all squared equals the hypotenuse squared. That is, A squared plus B squared is equal to C squared. And that's something you might have learned back in grade 6, 7, or 8. So again, definition of hypotenuse and the Pythagorean Theorem, and we can use PT for short to represent the Pythagorean Theorem, and that is that if I take side A and square that, plus side B and square that, that will always equal the hypotenuse squared. Or if in short, A squared plus B squared equals C squared. So let's look at some examples where Pythagorean Theorem is used. For example, example 1, you're asked to determine the value of the missing side. So we have some examples here of different triangles, and we need to solve for the indicated side, the missing side. So how do we do that? Well, looking at the first triangle, you have to identify where the hypotenuse is. So look for the right angle. The right angle points to the hypotenuse, and that's right, folks. 56 is your hypotenuse. So we circle that. So we know that one has to be left alone. So how do we set up the formula? Well, we're going to use PT because it's a right angle triangle, so we want to use Pythagorean Theorem, and we use that by saying, okay, A squared plus B squared equals C squared. Now remember, C represents the hypotenuse. So when we write it out, we write 12 squared plus X squared equals 56 squared. We can square each of these values, and once we square each of these values, we isolate for X squared. And once we've isolated for X squared, we can subtract and then take the, oh, that's right, folks, you saw that up there. What does that mean? That means we have to take the square root, because we're not looking for X squared, but we're looking for X. So we take the square root of both sides, and we get X is equal to 54.6992. Now some of you are going, oh, that's just 54.7. Or that might be, hey, that's not really the end of the decimal. Well, folks, the decimal in the calculator showed up to be something like this, 54.69917732. The standard rounding, if the question doesn't say to round it, so always be careful to check, does the question say rounding? No, it doesn't. So what do we automatically round to? We round to 4 decimal places. Why? Think of it this way. We always keep it 4 real, okay? So to keep it 4 real, we want to keep it to 4 decimal places. Because out in industry, there are many cases where decimal places are used, multiple decimal places, such as in banking and engineering. When we use trigonometry, we want to have 4 decimal places. Okay, so now we have solved for x equals 54.6992. Some of you, if you're not sure about rounding, what you do is you look at the fifth decimal place, okay, the 7 here, and because this number is 5 or higher, we automatically round this number up. So it'll become 6992, and that's why we have 6992 as our decimal here. All right, let's try the next example. So again, PT, Pythagorean Theorem, identify a squared plus b squared equals c squared. We're going to use the Pythagorean Theorem. Identify the hypotenuse. We did that. And now we can plug it in. So we have 45 squared plus 24 squared equals c squared. 45 squared is 2025 plus 24 squared, which is 576, equals c squared. Get c squared by itself, and we take the square root. That's right, we want to get rid of that square on the c. So we end up with an answer of c equals 51 meters. Now, a way to remember, folks, what the answers could be is this answer, for example, has to be less than 56. When we had 2,992, that was kind of big, especially for this problem. So our answer, we know, has to be less than 56. So for this example, we have 24 and 45. We know that this number has to be bigger than 45, but not such a giant number. So for example, 2601 is a really giant number. I can tell you right now, it doesn't equal that. When you take the square root, it equals 51. And we can say, okay, that number makes sense. So again, we have to be able to identify values in which the numbers make sense. Not only just plug things in, but understand why we need to get a certain number. Now, another special unique thing about this particular example is that this is known as a Pythagorean triple. What's a Pythagorean triple, you might ask? Well, that's when the numbers are exact. So this number is an exact number. There's no decimal. This number and this number, so we have exact numbers where we don't have to round a decimal. Pythagorean triples are used in real life, especially in construction, when trying to develop a true 90-degree angle. A true 90-degree angle, for example, in real life, somebody doing framing would measure 3 meters along one wall, 4 meters along another wall, and when they measure the diagonal, that diagonal has to actually equal 5 meters. Cool, eh? All right, last one we need to do is part C, and then we'll move on to some examples. So part C, what we need to do is use Pythagorean Theorem, and we're going to go a squared plus b squared equals c squared. Identify the hypotenuse. That's right, 12.5 is the hypotenuse because, again, the right angle points to where the hypotenuse is. And once we've done that, we can now plug into the formula. So plugging into the formula, we do the following. X squared plus 10 squared equals 12.5 squared. Okay? And once we've done that, we now have set up our formula. How about you pause the video right now and try and see if you can do the rest of this question and restart the video when you're done. All right. Hi, welcome back. So what do we need to do? That's right. We have x squared plus 100 equals 156.25. We move the 100 over. X squared is equal to 56.25. So we're going to subtract 100. So 156.25. Subtract 100 gives you 56.25. And don't forget, we know it's got to be less than 12.5 because this is the hypotenuse, the longest side. This number is way too big. Ah, that's right. We forgot to square root. So we need to square root both sides, and we get x is equal to 7.5 meters. So remember again, what you're doing is you have to take the square root of both sides in order to get that value. So x is equal to 7.5 meters. All right, now let's look at some examples. Example 2. A 4-meter ladder leans against the house with its base 1.4 meters away from the wall. Does the ladder reach a window 3.8 meters high? Show your work. So what we're going to do now is draw. That's right. When you have a question that looks like this, what we need to do is be able to visualize this using a drawing. the drawing can represent or replace things like let statements. Let x represent if you introduce a variable. So the beauty of this is if you can make a drawing, you can let go of your let statements. So let's do a drawing. So here's my wall and here's my ground. And I'm going to rest the ladder against the wall, okay? In such a way, we have this ladder. And we can assume, that's the one thing you can assume, that the wall and the ground make a 90-degree angle. Based on that, we know that our ladder is 4 meters long, and we know that it is stretched out 1.4 meters from the base of the wall. So its base is 1.4 meters away from the wall. So that's this piece right here. It wants to know, does this ladder reach a 3.8 meter high window? So this is the part we don't know. So instead of the question mark, what I recommend you do is replace the question mark with that's right, an x. Why an x? Well, now what we've done is said, okay, this is what I need to find. By doing that, we can also identify the hypotenuse, which is right here. We have the hypotenuse, we have x, we have 1.4. And guess what, folks? What we can do now is solve for x. How do we do that? That's right, Pythagorean Theorem again. Reminder again, don't forget that this right angle points to the hypotenuse, so that's located directly across here. So what we can do now is, using Pythagorean Theorem, we get 4 squared is equal to x squared plus 1.4 squared. So remember that the hypotenuse is always by itself. And what we do now is expand on these. So we get 16 is equal to x squared plus 1.96. Move 1.96 over, so 16 minus 1.96 is equal to x squared. And now what we're going to do, folks, that's right, we want to solve for x 16 minus 1.96, which is 14.04. And now what we're going to do is take the square root of both sides. And we get x is equal to, that's right, 3.7470. So we rounded it to 4 decimal places. The question over here doesn't say how much to round to, so we leave it at 4 decimal places. But wait, did we answer the question? No, we didn't. It says, does the ladder reach a window 3.8 meters high? Well, no. The ladder cannot reach the 3.8 meter window. It can't because it is a little bit short. And you can calculate how much little short if it says explain your answer. Okay, one more example, folks. So here we go. Example 3. Determine the area of the triangle. So here we have the triangle, a right angle, 57 centimeters over here, 28 centimeters over here, and that's all you're given. So we need to determine the area of the triangle. Now, a lot of you are going, okay, well, all we need to do is know the formula. Okay, great. Formula for a triangle area is base times height divided by 2, or base times height, half the base times the height. So either half the base times the height, or either or is acceptable, folks. Base times height divided by 2. That's another option. Now, what we need to do is determine the area of the triangle. To determine the area of any triangle, you need a base and a height that is perpendicular to that base. Here in this triangle, the way we have, this 57, folks, you might want to consider your base. But how are you going to find this height? That's right, you can't. We can't find this height, but I know my base. But wait, what kind of triangle is this? Yes, that's right. It is a right triangle. What does that mean for us to be able to calculate? Well, I know that if I have a right angle here, one of these could be considered my base. The other one can be considered my height because I have a right angle. If I move this so that the right angle is on its base, okay, then this could be my base. So you turn your page over and turn your page around, you can see that this will be your base and this will be your height because of the right angle. So if we actually found this value, we'd be able to use this value times this value divided by 2 to calculate our area. Interesting. So again, we call one base, the other one height, and we need to find the base. So how are we going to do that? Well, I know that using Pythagorean Theorem, it equals base squared plus 28 squared is equal to 57 squared. Because remember, Pythagorean theorem says base squared plus height squared equals hypotenuse squared. So base squared plus 28 squared equals 57 squared. And what I'm going to do is show you another way that you can represent your answer and you'll get full marks. And that is isolating for base squared. Base squared equals 3249, which is 57 squared, and minus 28 squared, which is 784. So you're going to take 57 squared and subtract 784. Once you do that, you find out that the base squared is equal to 246. I can tell you right now that number is probably not the answer I'm looking for. Sorry, 2,465. Definitely not the answer I'm looking for the base. So how long is this base? Well, we need to take the, that's right, square root. We need to take the square root of both sides. When you take the square root of both sides, you find out that base is equal to 49.6488 centimeters. That's right, 49.6488 centimeters. So, how did we do that? Well, reminder again, we took the square root of both sides. So that is our base. And the answer here makes sense because this should be the longest side, so this makes sense that it's less than 57. Now, we need to find the area of this triangle. How are we going to do that? Well, we have our base, we have our height, now we can find the area. Area equal to base is 49.6488 times the height, which is 28, all divided by 2. That's right, 49.6488, that's the base, times the height, 28, all divided by 2. And that means the area is equal to 695.0832 centimeters squared. Now, if you're wondering about the centimeters squared, remember this was centimeters times this being centimeters. Centimeter times centimeter always gives you centimeters squared. So that is the area of the triangle given right there. And funny enough, we weren't given those information right at the beginning. Now, if I asked you to round to the nearest tenth, just a reminder, if you round to the nearest tenth, that means that you need to round to one decimal place. So you do that in the therefore answer. Therefore, the area of the triangle is 695.1 centimeters large. All right. Anyways, that's the end of the video, folks. Have a numerical day.